Well, good afternoon. Miss Orban here. I just want to go over an organized way to solve multiple part energy problems using conservation of energy and what I call energy tables. So let's take a look. Here I have our problem. Using the law of conservation of energy, find the height of the box at point C. Well, I can see that I have my box at three different places, point A, point B, and point C. A lot of information is given on the actual picture, but I want to make sure that we're really able to organize this information. So I've created energy tables. Down at the bottom of the energy table, I have my variables. At the top, I have my types of energy. And right in the middle, I have my mechanical energy, the total mechanical energy. Each of the columns represents one of the positions of the box. So I have the box at position A, position B, and position C. So let's first evaluate what's going on at position A and see if we can start solving the problem there. So at position A, I have a box that is pushed up against a spring that has a velocity of 0, and it gives me some information about the spring here. K, the spring constant, and X, the distance the spring is pushed in. So I'm going to go ahead and put all the information I see here into my energy table, column A. I have the X, which is the compression of the spring, 0.56 meters. The H, the height of the box, is 0. And the velocity of the box here is also 0 meters per second. So what I can do here is I can go ahead and solve for my different types of energy. If I have no velocity here, then I cannot possibly have a kinetic energy. This is going to be 0 joules. If I have no height, I can't have any gravitational potential energy. So this is going to be 0 joules. If I have a compressed spring, then I absolutely do have elastic potential energy. So I'm going to go ahead and solve for that down here in the work area. PEK is equal to 1/2 kx squared. K is found up here as 2,000 newtons per meter. So I have 0.5 times 2,000 newtons per meter multiplied by that 0.56 meters, and I'm going to square this. When I do this, I find that the elastic potential energy is equal to 313.6 joules, which I just put directly into my chart. Now I can take all my types of energy, add them up, so Ke plus PEG plus PK, and that's going to equal my mechanical energy. Here it simply equals 313.6 joules. Between point A and point B, I do not have friction. So I can say the mechanical energy has been conserved. Because of this, I can go ahead and transfer this number from point A to point B. So 313.6 joules. I now take a look at what my box is doing at point B. At point B, I have some velocity I do not know. This is an unknown quantity. I have still a 0 height, and I don't have a spring to compress. There's no symbol like this, so there is a 0 meter compression of the spring. Since there is no spring, I have no elastic potential energy. Since there is no height, I have no gravitational potential energy. So that means that all of my energy must be kinetic. Here I have 2 different empty spaces. However, I can use the total mechanical energy to know that all of my energy must be kinetic energy, so this quantity is 313.6 joules. Now that I have the kinetic energy, I can go ahead and solve for the velocity. Scroll down here. Kinetic energy is equal to 1/2 mv squared. I'm going to solve for v to be the square root of 2 times Ke over m. M mass can be found on the actual box here. And if I do this calculation correctly, I should find that the velocity is 12.5 meters per second. Now, I'm almost done with the problem. I have to look to see, make sure that energy is being conserved between point B and point C. I don't see any frictional patches. So I can assume here that this 313 actually does transfer over. So 313.6 joules. Now that we know that, we have to look to see what else is going on. Here it indicates that the velocity is 0. So I'm going to go ahead and put that in for my velocity, 0 meters. I see no spring, no symbol like this, so I can say that the compression of the spring is 0 meters. I do not know the height. That is the entire question. So I'm going to leave that blank and see what else we can figure out. If I have no velocity, then I have no kinetic energy, so that's going to be 0 joules. If I have no spring, I have no elastic potential energy, and the only thing I'm left looking for is the gravitational potential energy. Well, 0 plus 0 plus what equals 313.6? You're right, 313.6 joules. Now that I know that, I can go ahead and solve for the height. Coming down here, I have PG is equal to mgh, where g is equal to 9.81 meters per second squared. If I solve for h, I get that h is equal to the gravitational potential energy divided by mass times gravity. So if I'm going to plug in this information, I should get that the final height is 7.99 meters. What I would like you to do is print off the attachment that is another energy table similar to this one, and I want you to try it on your own now. Tomorrow we'll go over in class. Thanks for listening and hope to see you soon.